This is the second class of integral transform of vector calculus, and in this class we discuss about an important theorem known as Stokes Theorem, right, together with an important application of this theorem. Now we first see what is Stokes Theorem. If S, this is the surface, be open two-sided surface bounded by a closed non-intersecting curve C. Closed and non-intersecting, this is called simple closed curve. So our surface and curve look like, this is the closed curve, this is also non-intersecting curve, and this is the surface like hemisphere. Okay, and its surface has two sides. This is the inner side and this is the outer side, and the curve is taken in anti-clockwise direction. Okay, now if a vector is continuous derivative, this means a vector, if this is equal to f1i plus f2j plus f3k, then del f1 by del x, del f1 by del y, del f1 by del z, all are continuous derivative. Okay, and similarly for f2, f3, all, right. This means the continuous derivative. Then Stokes theorem states that integration over C, this is also known as circulation, and this is the line integration f dot dr, and this is equal to double integration over S curl f dot n ds, or it can be written in the form curl f dot ds. Here ds, S is scalar element, and the direction of S is the normal, unit normal, this is n, and here this is vector element. Okay, now if we take small surface S, and this is like this, and this is the direction of the surface, this is n cap. Okay, this is unit normal to the surface, S or ds, this is ds. Where C is taken in the positive sense, that is in the anti-clockwise direction, and n cap is the unit outward drawn normal. This is the statement of Stokes theorem. Okay, now here we take f, this is equal to f1i plus f2j plus f3k. Now dr means dxi plus dyj plus dzk. This is k cap, j cap, I cap. Then f dot dr, this means f1 dx plus f2 dy plus f3 dz. This is f dot dr. Now we find curl f or nebula cross f. This is the same symbol. This is equal to I cap, j cap, k cap, del x, del y, del z. This is f1, this is f2, this is f3. So it is I into del f3 by del y minus del f2 by del z minus j into, this can be taken also as plus j into, this is del f1 by del z minus del f3 by del x plus k into del f2 by del x minus del f1 by del y. Okay, this is del, this is minus, sorry, this is minus. Okay, now if we put this value, that is the value of curl f and the value of f r, now we find n cap. Let this unit normal or this outward unit normal makes angle alpha, beta, gamma with positive direction of x, y, z axis respectively. Right? Then n cap dot I, this is obviously cos alpha, because this is equal to cos alpha into mod n cap into mod I cap, right? So this is cos alpha. Similarly, n cap dot j, this is equal to cos beta, and n cap dot k, this is equal to cos gamma. These are also cap, right? So we get n cap, this is equal to cos alpha into I cap plus cos beta into j cap plus cos gamma into k cap. And by putting the value of correlate, putting the value of f dot dr and n in this formula, we get this is equal to circulation over c f1 dx plus f2 dy plus f3 dz. This is equal to double integration over s, the value of correlate and the value of n, the dot product of these two values is given by del f3 by del y minus del f2 by del z into cos alpha plus, here we reversing the term del f3 by del x minus del f1 by del z into cos beta plus, this is del f2 by del x minus del f1 by del y into cos gamma, right? And this is ds. This is the another form of Stokes theorem. We get this result from Stokes theorem directly by putting the value of f and n. Okay, and this Stokes theorem is called the rectangular form of Stokes theorem. This is called rectangular form. Of Stokes theorem. Okay, this is the rectangular form of Stokes theorem. In this problem, it is given that verify Stokes theorem for f, which is given by 2x minus y z square and minus y square z, when s is the surface x square plus y square plus z square, this is equal to 1, and z greater or equal to 0, and c is the boundary. We draw a rough sketch of the given surface and the given path C or curve C, and this is given by, looks like this is taken as x-axis, this is taken as z-axis, and this is y-axis. So this is the base of the hemisphere and this is the hemisphere, right? This is the base and let it be C, and the surface is this is S. Okay, and this is x-axis, this is origin, y-axis, z-axis. This plane, the plane of the circle C or the curve C, this is equal to, this is z equal to 0, and this is x square plus y square plus z square, this is equal to 1. Now we first find here n cap. N cap means grad phi by mod grad phi, where phi is the given surface x square plus y square plus z square minus 1. So grad phi is I del phi by del x plus j del phi by del y plus k del phi by del z by mod grad phi. Okay, so we get clearly del phi by del x means 2 into ix plus iy plus jy plus kz by root under 2 into x square plus y square plus z square, and this is obviously equal to 1, so we get this is xi plus yj plus zk. This is our n cap. Now we find curl f. Curl f. This is given by I, j, k, del x, del y, del z, and the first component is 2x minus y, second component is minus yz square and minus y square z. So this is I del y square z by del y, this is minus 2yz minus, this is plus 2yz plus j into this is 0 minus this is 0 plus k into this is 0 minus this gives minus of minus 1, so this is k, right? So we get curl f, this is equal to k vector or k cap. We find curl f dot n for the surface integration. We get curl f dot n cap. This is equal to k dot. This is n cap means xi plus yj plus zk, yj plus zk, and this is z only. Okay. Now we first find the right hand side integration, that is the surface integration. So we get double integration over s curl f dot n cap into ds. This is equal to double integration over s z dot, sorry, this is z, this result is z ds. Okay. Now here we project the surface S. We project the surface S on xy plane. The projection of the surface S is given by a circle, this circle, okay, this circle, and this is a region, let it be R, right? And the region R, this is given by x square plus y square, this is equal to 1. This is the surface on xy plane, and then we get this integration or ds, this is equal to dx dy, right, by mod n dot k, because we project this surface on xy plane, so the normal of xy plane is k and the normal of this surface is n, and this is given by dx dy by mod n means we already find n, this is xi plus yj plus zk dot k, and this is obviously z, and this is dx dy by z. Okay, we put the value of ds and get double integration z into dx dy by z, so only dx dy. Now for the circular region R, if we draw circular region and we take here the limit of x and y, and let the limit of x, this is equal to minus 1 to 1, and then the limit of y, this is equal to minus root under 1 minus x square to 1 plus x square, right, and this is only dx dy. So integrand is only 1, so this is an even function, and we take or we write the integration as integration 0 to 1, integration 0 to root 1 minus x square, this is 1 minus x square, 4 into dy dx, and integrating we get 4 into integration 0 to 1 root 1 minus x square, and this is dx, and this is given by 4 into x root 1 minus x square by 2 plus a square by 2 means half into sine inverse x by 1, and the range is 0 to 1. For both the limit 0 and 1, this term must be 0, and from this relation we get this is 4 into half into pi by 2, because sine inverse 1 means pi by 2 and sine inverse 0 means 0. So this is given by pi. So the right hand side of this term is equal to pi. Now we have to find the left hand side of this Stokes theorem, and we have to show that this is also be equal to pi, and then the problem verified, or then the Stokes theorem verified. For the line integration over C, here C is a circle. This is given by the boundary of x square plus y square, this is equal to 1 and z equal to 0. So we put x equal to cos theta, y equal to sin theta, and that is dx, this is equal to sin theta d theta minus sin theta d theta, and dy, this is equal to cos theta d theta. Now we put the value of x, y in the left hand side. We get integration or circulation over C f dot dr. This means circulation over C. This is 2x minus y into dx minus y z square into dy minus y square z into dz. We first put z equal to 0. So we get this is integration over C 2x minus y into dx only, because here is z and here is z. So second and third term be 0. Now for the circle, the range of theta from 0 to 2 pi, right? So the integration theta, this is equal to 0 to 2 pi. We put the value of x, this is 2 cos theta minus this is sin theta, and this is dx. Dx means minus sin theta d theta, and this gives minus integration 0 to 2 pi. This is 2 into sin theta cos theta, that is sin 2 theta minus sin square theta d theta. So we get minus, the first integration is cos 2 theta by 2, this is also minus, and the range is 0 to 2 pi. And for the second integration, this is plus, we multiply it by 2 and half, this is 2 sin square theta d theta, 0 to 2 pi. This integration is obviously 0, because cos 4 pi means 1 and cos 0 is also 1. So this part is 0, and the second part is half into integration 0 to 2 pi. This is 1 minus cos 2 theta d theta. And the value of the integration is, this is half into theta minus sin 2 theta by 2, and the range is 0 to 2 pi. So from here we get half into 2 pi minus 0, this is pi, and the left hand integration is also pi. So we say that Stokes theorem verified. Okay, this is an important problem for Stokes theorem. So this is the today's class. Thank you for watching.